Today we're going to look at adding and subtracting radicals. The concept is actually quite similar to that of collecting like terms with polynomials. We know that to collect like terms, we identify like terms having the same combination of variables and exponents and then add the coefficients. So if we start with something very simple, let's say we'll consider 2x plus 3x, variable being x with exponent 1, exactly the same, so coefficient 2, coefficient positive 3, when we combine those, we know that that equals 5x. So then, if we substitute in x equal to square root of 7, then we would have 2 root 7 plus 3 root 7, and again, now our like terms are root 7. So 2 root 7 plus 3 root 7 is then 5 root 7. If we go ahead and add in additional variables or additional types of terms, we might have something such as 2x plus 5y minus 6x. And so now we look at our like terms again. So we have 2 x's, negative 6 x's, so those can be combined to give us negative 4 x's, but the y's, there's nothing else alike, so they must still be included, so we have negative 4x plus 5y. So again, if we substitute in x equal to square root of 7, and this time we'll add in that y is equal to, let's say, square root of 11, I can then say that 2 root 7 plus 5 root 11 minus 6 root 7 is going to give me negative 4 root 7 plus 5 root 11, and that's as simplified as it gets. We can of course check this using our calculators by entering in the original expression into our calculator. We know that we would get a decimal approximation because of course it's an irrational number. We can then enter the simplified expression into the calculator, and the decimal approximation should be identical. And so you can see there's that original 2 root 7 plus 5 root 11 plus 6 root 7 is approximately 6 decimal 0, 0, 0, and so on. The equivalent expression, simplified expression, negative 4 root 7 plus 5 root 11, has the same decimal approximation. So remember as well that just as the coefficient of x is equal to 1, then the coefficient of something such as root 7 is also equal to 1. So, of course, examples might simply be x plus 3x, we know is 4x, so root 7 plus 3 root 7 would then be the same as 4 root 7. So, of course, the question is, does it get much harder than this? And you know the answer is yes. So let's try a couple more examples then, using the skills that we learned previously in working with mixed and entire radicals. So if we have something such as square root of 18 plus square root of 50, well, can we combine those? Immediately, the answer should be no, because of course these are not like terms. We also recognize that when we looked at that example previously, square root 9 plus square root 4, it does not equal the square root of 13. We cannot combine those. So what are we left to do is hopefully we recognize that the square root of 18 can be simplified because there is a perfect square factor. So root 18 is the same as root 9 times root 2. Square root of 50 is the same as root 25 times root 2. So root 18 simplified is 3 root 2, and root 50 simplified is 5 root 2. Conveniently, you can see that we now have like terms or like radicals, and so together that equals 8 root 2. Let's try another one. So rather than giving you 2 entire radicals, I'll give you some mixed radicals. So let's take a look. 5 root 12 minus 8 root 27 plus 3 root 32. So again, immediately, there's no possible way to combine those terms because they are not like radicals. But of course, root 12 can be further simplified, so we can look at this as 5 times root 4 times root 3 minus 8, and root 27 can be broken down to root 9 times root 3, and 3 root 32 is root 16 times root 2. So we're looking at 5 times 2 root 3 minus 8 times 3 root 3 and 3 times 4 root 2. Cleaning it up a little bit more, we have 10 root 3 minus 24 root 3 plus 12 root 2. So we have 3 terms, 10 root 3 minus 24 root 3 plus 12 root 2. Which of these are like terms or like radicals? The first two have root 3, so those combine to give us negative 14 root 3 plus 12 root 2. And again, if you wanted to check your work using your calculator, you could enter in this very first original expression into your calculator to give you a decimal approximation, and then again enter in that simplified form and hope that it also gives you an equal decimal approximation. We're also double checking that the radicals that we have are in simplest form, so root 3 and root 2 cannot be further simplified, and so it is in fact in simplest form. Let's just do one more example, and we'll throw in some cube roots. So the cube root of 24 plus 6 times the cube root of 375. So again, now that we're dealing with cube roots and we want to simplify, check, do we have like radicals? Definitely not. So to simplify, is there a perfect cube that is a factor of 24? And hopefully you have thought of 8. So we're looking at cube root of 8 times the cube root of 3, because 8 times 3 is 24. Then 6 times, and the factor, perfect cube factor of 375 would be 125, so 6 times the cube root of 125 times the cube root of 3. So cube root of 8 simplifies to 2, so 2 cube root 3 plus 6 times cube root of 125 is 5, cube root 3, or 2 cube root 3 plus 30 cube root 3 then gives us 32 cube root 3. If you happen to be stuck on the cube root of 375 and trying to figure out what is your perfect cube that is a factor of 375, if you've already finished one part of a question where you're simplifying and perhaps combining like terms, again, use that as a possible clue. Because this one simplified to 2 cube root 3, and the idea is to collect like terms, it's always worth checking. Perhaps then cube root of 375 is equal to the cube root of 3 times the cube root of something else. And so that gives us a little clue. Perhaps we can divide 375 by 3, come up with another factor, and hope that that is your perfect cube. So that's an idea of what you might try if you're stuck on a big number. Anyways, hopefully that's enough examples. There are additional examples, of course, available online, and you can talk to me when I return.